Hello, welcome to this Gespy build stuff video. In one of my previous videos I showed that I had imported an Atari 400 from the US to Europe. I had taken it apart and refurbished it. But before I put it back together, I measured the voltages coming from the power board. This was to ensure that the voltage did not come too high, which could damage the computer. And it turned out that the voltage was indeed too high. So the Atari 400 seems to be defective. What can I fix yet? We're gonna try that in this video. Welcome back. Here we have that Atari 400. Let's recap what we discovered in the previous video. After taking the Atari 400 apart, we discovered that the Atari 400 consists of two boards. The main board and the power board. The power board uses 9 volts AC and convert that to 5 volt and 12 volt DC. I connected the power board to the 9 volt power supply to measure whether they were indeed 12 and 5 volts. The 12 volts did indeed came out the board, but the location where 5 volts should come out, I measured 11.8 volts. So that wasn't right, and now let's see if we can fix this.
How's business?
Booming!
Terrific. How do you keep track of your customers?
My Atari 400 home computer. Excuse me, Dad.
Why Atari?
Shopped around. It's a lot of computing capability for such a low price.
You use it a lot?
Shut up. Life's not all fun and games. There's homework. I even program. Atari has lots of software. Not all the others do. And of course, only Atari has games like Centipede.
Games?
Well, we executives have to unwind.
Atari home computers. Only Atari puts so much in it for you.
Here we have the power board. With the cloth pin on the switch, I ensure that the power stays on. This is where we measured the last time. And we still measured 12 volts instead of the 5 volts. The 5 volts must be provided by the 7805 voltage regulator. The 7805 ensures that the voltage connected to the input is kept at 5 volts. Let's measure what comes out of the output of this 7805. I found the ground connection here. I get 13 volts at the input and we have 12 volts at the output. There's a good chance that this 7805 is defective. Let's replace it. You need to remove the 7805 from the heatsink first. It's loose. Now desolder it from the board. We first add some new solder. It's better if we remove all the remaining solder. With a little wiggle, we can then pull it out. We remove the remaining thermal paste with a little alcohol. We also clean the solder islands with the alcohol. Here I have a new 7805. Let's see if it fits first. Oh, there is a little bit too much solder in the holes. I moved that a little more. Before we assemble it, we put a little bit of new thermal paste on it. Oops, that's way too much. That came out of the tube much easier than I thought. We divide it well and wipe off any excess. It must be placed so that the screw hole is in line with the hole in the heatsink. Tighten it, a lot of thermal paste still comes out. We can remove that with a Q-tip. Now that's in place, we can solder it to the board. That's done. But I also want to replace these capacitors. These old ones can have lost their capacity, but can damage the computer. Here I have a set of new capacitors. The new models are a lot smaller than the old ones, but that doesn't matter. I'll start with the big ones. First add some new solder. After that, they are quite easy to remove. We remove the remaining solder again. After we have bent the legs to the right size, we insert them into place. The electrolytic capacitors are polarized, so they have a plus and a minus, so be careful that you place them in the correct position. Fortunately, the minus is clearly indicated on both the capacitor and on the board. We bend the legs a bit so that the capacitor stays attached to the board. To be sure, we check whether the polarization is properly connected and we can cut off the remaining legs. That's one. Now the next one. After these two, on to the next two. The new ones are also clearly a lot smaller. That's done. And here we have also two very small ones. These have now also been replaced. Then we still have this big one left. The new one is really a lot smaller. This one has radio mounting. We can see that the old one has 3 connection pins. And the new one only has 2. But the third one only served for reinforcement in the old one, and it had no further function. so we can just leave that hole empty. That's done too. It also looks a lot cleaner with those smaller capacitors. Now we can start measuring. Still 11.8 volts. How is this possible? Time to take another look at the power board's schematic. In the middle we see our 7805 voltage regulator. On the right the 12 volts comes from the rectifier and on the left the 5 volts goes to the connector. But what do we see up there? A resistance of only 33 ohms? This connects the input with the output. Could that cause the 12 volt on the output? I have to Google to see if I find anything about this resistor. Then I came across the Atari Age forum. Atari Age is really a fantastic site where you can find a lot about Atari. I came across a post of someone who had exactly the same thing I had. Also 11.8 volts on the output of the 7805. He also had the 7805 and all capacitors replaced. As I continued reading, I came across a post where someone explained the function of this resistor. This is a cheap solution to get more power than the 7005 can supply. And it is indeed true that if the power board is not connected to the main board, you measure almost 12 volts on the 5 volt connector. So the power board is probably not defective at all. Let's perform the measurement again, but now with the power board connected to the main board. Power supply is connected and the ground is connected to my voltmeter. I turn on the power with the cover switch. And now look for pin number 5. And indeed, exactly 5 volts. So the power board just works fine. Then we can finally test the Atari 400. The 400 only has RF out, and this connector is on the end of the cable. To connect it to a European television, I made this converter. Okay, the computer is connected to the television. I also connected the keyboard. Turn on the computer and a blank screen. Ah, that's a shame. What now? The memory card and the CPU board are the same as in the Atari 800. I have now swapped both with the ones from my 800, which I'm sure of that works. See if the 400 will work now. No, also a black screen. Shame. Now it's getting very difficult. So, this requires some more research, but that will be probably a part 3 video. In the meantime, I can use any help. So, if you have any idea what else I can try, let me know in the comment section below this video. I hope we found something. I would love it if we could get this thing working again. With this we come to the end of this video. I would really appreciate it if you click on the like button and subscribe to this channel. For now, until the next Gespy build stuff video, bye!